Hello everyone, in this video we'll be going over equivalent expressions where we try to change each of these subtraction problems to an equivalent addition problem. So let's go over our first example. Here we have 9 minus 6. What are some ways of thinking about this problem here? I could think of this as I have 9 of these tiles and I want to get rid of 6 of them. So I can grab 6 of them, drag them away, and I know my answer would be 3. But what would be another way of getting rid of these 6 tiles? Well, one way of getting rid of them would be to introduce their opposites. So if I want to get rid of these 6 tiles, I can introduce 6 negatives. Notice how when I have a red and a blue tile, again, I have 2 opposite sides. These are going to cancel out and leave me with 0. So again, another way of thinking about this would be, if I have those 9 tiles and I add in 6 negatives, these 6 positives and these 6 negatives are going to cancel out. I'm still going to be left with my answer of 3. So an equivalent expression would be 9 plus negative 6. Alright, let's go over our next example. Here I have negative 5 and I want to take away 2 negatives. So one way of thinking about that is that I can grab 2 of these negatives, drag them away, and my answer would be negative 3. But what would be another way of getting rid of these 2 negatives? Well, one way is to introduce their opposites. So if I want to get rid of these 2 negatives, I could introduce 2 positives. Right? And here I have the expression negative 5 plus 2 positives. I know that these 0 pairs are going to cancel out. I'm still going to be left with my answer of negative 3. So an equivalent expression would be negative 5 plus 2. Right? Let's go over our next example. Here we have 12x minus 4x. Again, I can think of this as I have 12 of these x tiles and I want to get rid of 4 of them, and my answer would be 8x. But what would be another way of getting rid of these 4 tiles here? Well, another way of getting rid of them would be to introduce their opposites. If I want to get rid of these 4 x's, I could introduce 4 negative x's. These red x's will cancel out with these blue x's, leaving me with my same answer as 8x. So an equivalent expression would be 12x, and I introduce 4 negative x's. Right. Our next example. Here I have 11x take away negative 6x. So starting with negative 11x's, I can think of this as I want to get rid of 6 of these x's. So if I get rid of them, I will have an answer of negative 5x. But what would be another way of getting rid of these? So instead of just taking those away, I could introduce their opposites. If I want to get rid of those 6 red x's, I could introduce 6 of these blue x's. I know opposites are going to cancel out, so these red x's will cancel out with these blue x's, and I will be left with my same answer of negative 5x. So an equivalent expression would be negative 11x plus I'm adding in 6 positive x's. So when is this going to be useful? So this would be useful when we have a subtraction problem where we're trying to take away more than what we have. So for example, we'll have 5 take away 10. Again, here I have 5 tiles and I want to get rid of 10 of them. Notice how we don't have enough tiles to drag away. So this would be useful to introduce our adding the opposite. So here, I know that I want to get rid of 10 of these blue tiles. So another way of thinking about it would be to introduce 10 of these negatives. Right? So I can take those 5 and introduce 10 of those negatives. Right? I know that these are going to cancel out, and I'll be left with the answer of negative 5. Right? Let's go over our last example. Here I have negative 3x, and I want to take away negative 4x. Again, as you guys notice, we don't have enough tiles to drag away here. So this is where introducing the opposite would be useful. Okay? Again, I want to get rid of these 4 x's, these 4 negative x's, and one way of doing that is by introducing their opposites. I can introduce 4 of these positive x's. I know that 0 pairs are going to cancel out. So an equivalent expression would be negative 3x plus 4x. And after canceling these out, I'll be left with an answer of just x. So just keep in mind, every subtraction problem can be written as an equivalent addition problem, where we can subtract, when we subtract a number, we can just add in its opposite.